the last section to review nonlinear functions. And models. Okay. So one more time concerning group work. If I see the same work, I will not be able to give credit. So just make sure that you're discussing, but the write-up is individual. Okay. So we have a lot of functions that are not linear. So we have a lot to review here. So a lot of these functions will be presented again later, and when we learn techniques of graphing. But let's just go quickly through number one, quadratic. So quadratic functions are not linear, of course, and the general form will be f of x, a number, x squared, plus a number, x, plus another number, where a, b, and c are real numbers, but a cannot be 0. Because if a is 0, this becomes linear. But b or c can be 0. So quickly, the review of a quadratic function. A quadratic function either looks like this, having a minimum, in which the leading coefficient is a positive number. This point, which is the minimum, is also called vertex. And it also has an axis of symmetry because this piece is symmetric of this piece with respect to the axis of symmetry. So this is an axis of symmetry. Same thing with the other possible shape, of course with a maximum. Everything the same, but the leading coefficient is a negative number this time. This point is still called vertex. It still has an axis of symmetry, but this time it opens downward versus opening upward. It has a maximum versus a minimum. Anyone remembers the coordinates of the vertex?
H and K.
Say it again.
H and K.
Very good. Very good. But not for this. For this form. Very good. So the quadratic function can be presented like this, or it can be presented with a completed square. If it's presented with a completed square, yes. H comma K. Perfect. I completely agree. But if it's not presented with a completed square, then it's negative b over 2a, negative b over twice a, with minus in front, right? Negative b over twice a, and the function value at that value. This is negative. Now, if we want to solve the quadratic equation, can anyone give us the quadratic formula? Notice that the equation has to be in the polynomial in descending order and equal 0. Anyone gives us the quadratic formula, please?
Negative b plus minus the square root of b squared minus 4ac divided by 2a.
Somebody must have tortured you last year with this. It was me. Well done. Thank you. Okay, so this is the quadratic formula. We can solve any equation. And of course, if this quantity is negative, if b squared minus 4ac is negative, then the solutions are imaginary. So would you like to choose a function to graph? Can anyone get into okay, I couldn't get into any of this, so I pulled up my tablet. So we can look at these functions. We have the equations. Let me see, it's page 64. So these are the quadratic equations. Apparently they don't want us to we also have here a quadratic equation, but they only want us to find the vertex if the graph is a parabola. State whether the graph of the function is a parabola, find the vertex. So anyone would like to choose? From 1 through 6, these are the quadratic functions, just simple ones.
4.
4? Okay, so we want to graph x squared and then x squared minus 3. Yes, we are using transformations on this. Good. So the simplest possible quadratic equation, simplest possible, is x squared. That's the easiest, the simplest base function. And this is a nice function. It has the vertex at the origin. And this is the graph. Can anyone give us the domain for all polynomials? For all polynomials, what is the domain? Good. All real numbers, always. The domain of all polynomial functions, linear, quadratic, cubic, any polynomial function, I call it friendly. Okay. Now, if I want to graph the graph of, let's say, g of x, which is x squared minus 3, what will happen? Anyone remembers what happens here? What transformation is this?
It shifts down 3.
Very good. Awesome. Down 3. So the graph has the same shape, but is down 3. So this is x squared minus 3, and this one is x squared. Now, what if I want to graph this function, f of x, f1, to differentiate it from that? f1, let's say x minus 2, everything squared. So this is still from the family of x squared, of course, quadratic. This is x squared. But when I change x into x minus 2, what do I really do to the graph? Very good, awesome. Thank you very much. Who was that, Lake? Thank you. So this is x minus 2 squared. If I have f of x or f2 of x equals x plus 3 squared, the graph will shift to the left 3. 1, 2, 3. And it's right here. Same shape. So x plus 3 squared. Okay, so that is the quadratic function. Now, if I have a function like, let's say, f of x equals x squared minus 6x plus 8, and I want to just find the vertex. Of course, the axis of symmetry is the vertical line passing through the vertex. So this will be x equals negative 3. The vertical line passing through this vertex will be x equals 2, and so on and so forth. So how do I determine the vertex, the coordinates of the vertex for this?
-6 over
Right.
2.
Yes. So x will be, the x of the vertex will be negative b over 2a. Negative, indeed. The top is -6. The denominator is
2 times 1
very good. So then the answer is
is 3.
very good. How do I determine this, the y coordinate of the vertex?
It's the function of negative b.
Thank you very much. Thank you. Who said that? Lake again? Thank you. So this is 3 squared minus 6 times 3 and plus 8. So 9 minus 18 plus 8. So this is 17 minus 18, -1. By the way, does this function open upward or downward? Does it have a max or a min? The vertex is a max or a min?
A minimum.
Right. So because a is 1, which is positive, the function has a minimum. What is the axis of symmetry? Indeed. Does this function cross the x-axis or not?
Yes,
How do I know?
because the minimum is -1.
Very good, awesome. The minimum is here. It opens upward, so it has to cross the x-axis. So here is the axis of symmetry. So let's find the x and y intercepts. How do I find the x-intercepts for any function?
Set y to 0.
Yes. So then we have x squared minus 6x plus 8 equals 0. If it's factorable, let's factor it. If it's not factorable, let's use the quadratic formula.
-4 and -2.
So then x equals 2 and x equals 4. So as expected, 2 and 4. They have to be symmetric with respect to the y-axis because this is a symmetric curve, symmetric with respect to the axis of symmetry. And now, can anyone give us the y-intercept for this?
Set x equal to 0.
Very good. So f of 0. So how much is f of 0?
8.
Very good. 0, 8. Great job. Good. So 2, 4, 6, 8, because I don't have enough room. I did not plan ahead correctly. So I did not leave enough room. Try to make it as symmetric as possible with respect to the axis of symmetry. We always write on the graph somewhere what we just graphed. So this is x squared minus 6x plus 8. So we know.
I have a question.
Yes, please.
The axis of symmetry, you said that x equals 3. Is that always going to be the h value of the vertex?
Always. It's the axis of symmetry. It's the vertical line through the vertex, and there is only one vertical line through the vertex. It's where the x is. Absolutely. So this has its x plus 3. The axis of symmetry is x equals -3. This one is x squared. The axis of symmetry is 0. X equals 0. This is x minus 2 squared. The axis of symmetry is x equals 2. And this will always be the minimum or respectively the maximum. This is always the axis of symmetry. This is always the min or max, not both. It's either or. Very good. Okay, moving on. The next in line will be general polynomial functions. And they have degree 3, 4, 5, and so on and so forth. What about linear? Yes, but we talked about linear a lot. What about quadratic? We just finished it. So when we really refer to polynomial functions, we really talk about higher degree than 2. Otherwise, we would have said quadratic, and definitely not linear. We would have said linear. So this is a little bit more complicated. We will graph them later. So let's see, again, because I just could not, for some reason, myself, have to log in all the time. Okay, so the polynomial functions here, come on, it's embarrassing me. Okay, okay, is it working now? Okay, it's waking up. Okay, polynomial functions, stay, that are here listed are just x cubed and some transformations with x cubed. So I'm just going to do that. So at least x cubed to see how it looks like, and maybe x to the 4th. So let's look at that. So let's say x to the 3rd, and later on f of x equals x to the 4th, just to have an idea of how they look. So x to the 3rd, because we may encounter it later. So x to the 3rd is a graph like this. And you will see what happens here at this point. How come that it takes its time? Because there are 3 solutions. X to the 3rd equals 0 is an equation, polynomial degree 3. Because the polynomial has degree 3, I have to have 3 solutions for this equation. So I get x equals 0 3 times. Okay? We call that multiplicity 3. Multiplicity 3. So if a solution appears once, the graph will have a straight cross. Straight. But here there are 3 solutions, x equals 0. And you can say, how come? What are you talking about? What I'm saying is that there is only one solution. But because the solution appears 3 times, then the graph takes its time. Slowly, slowly, crossing only once, but it takes its time. It gets to it in much slower than this when it's one solution. Okay, slow, 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 cross, slow, 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 going up. So that's what happens when a solution, we say, appears 3 times.